Okay, oh, we are recording now. Guys ready? So just smile and say, yes, of course we're ready. It's morning and we're happy. And yeah, who are my physics people and who in physics that kind of do distance displacement? A lot of you are not, and this is for the benefit of everyone because if you're in physics, we're going to do this from a calculus perspective, and if you're not, we kind of need to re-explain everything. So I'm going to start with a question to the cross-country runners in the crowd. What is the displacement? What is your displacement on our cross-country course? Essentially 0. It's actually just a few meters back because the finish line is not quite where the start line is. Close. But I think everyone gets the general idea of displacement, that it is not just how far you go. It's what's the difference between your final position and your initial position. On a three-dimensional thing, I could do all this wiggly stuff, but if you come right back to here, my displacement was 0 if I end where I started. In a two-dimensional thing, it can be a little bit trickier to do in 2 dimensions just because it shouldn't be. But if I go here and I'm a particle and I bounce back and then I go 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 back, but I end up here, my displacement would be the difference between those two positions. Displacement has everything to do with starting and finishing value. It has nothing to do with what happened in the middle. Okay? Displacement, everything to do with start and finish. So I'm going to say start and finish matter, and nothing else does. So if I want to say start and finish matter, then define the displacement of a particle moving along the x-axis between t equals 0 and t equals 2. What am I truly finding here? What do I need to know? Not even that. Yeah, position in each of those different values. So basically it's saying where the particle was at t equals 0 and t equals 2, which is really saying what is s of 0, which in this case is 4, and s of 2, which is the same as negative 12 plus 4 plus 4, or negative 4. So the particle started at 4 and it ended up at negative 4. What's its displacement? 8. Displacement is also an absolute value. Oh, you know what? I lied about that one. Displacement is not absolute value. So this wouldn't be 4 to 8. If I go 4, the difference between 4 and 8, no, this is 8. Wait, am I trying to say that right? Hold on, I'm pausing for a second while I get my head checked. Yes, you can. You can yell and say that. Go. Mm-hmm.
Hello, we miss you. Get well soon.
Okay. Now, if I have the ordered pair 2, 4, and I'm like, if I'm saying at t equals 2, my position is negative 4, and at t equals 0, my position is 4, then to get from my negative 4 back to the 4, I moved negative 8 units. In other words, I kind of started here at 4, and I moved in this direction to negative 4. So that is a displacement of negative 8 units. The change in my position moved left 8 units. I was confused because oftentimes with displacement we talk about a direction and a magnitude. So we talk about things like I moved left, which would be the interpretation of the negative sign, 8 units. In 3 dimensions we talk about a direction in terms of an angle. Sorry, more in 2 dimensions. Sorry, this is 1 dimension. I'm messing up my dimensions here. I kept calling this 2 dimensions. This is actually 1 dimension. 2 dimensions is a grid. 3 dimensions requires like a different coordinate system. So let's get back to number 2. Find the displacement of a particle moving along the x-axis whose velocity at any time t is given by this. So this is a similar question, but I'm actually asking for the velocity. And what I can think about is displacement is an accumulation of area under a velocity curve. Because if the integral of velocity is position, and I start to accumulate multiple positions, that accumulation of multiple positions becomes the integral. It becomes like not just a sum of positions, it becomes how far it moved. So if it's an accumulation of area under a velocity curve, that's an integral of velocity, negative 6t plus 2 dt, evaluated from 0 to 2. And that does give me negative 3t squared plus 2t, evaluated from 0 to 2. And that also, you're going to find, gives me negative 4. Do you see how that equation was related to the one right above it? It's actually the derivative. The v of t was the derivative of the one right above it. And so, in general, the displacement of a particle between t equals a and t equals b is given by the integral of the velocity from a to b. If I have a velocity curve from a to b, and I do an area under the curve, that area under the curve represents the displacement, how far I traveled. So that is displacement. Displacement is affected by negative and positive area. So this is why, what's the displacement of a sine curve? 0. Alex? When I plug in, is it supposed to be plus 8? Oh, it should be negative 8. You're right. It should match the same one as right above. I was looking at the wrong numbers. Kendall's going to be confused, but that's okay. Thanks, Alex. Nice check. Okay, questions so far about the concept? I know it's going to be a little foggy for a little bit, but displacement is kind of a singular one. We'll revisit it continually. Let's go down to the next set. Position. I'm going to kind of do a little here. Position is a location. And on a one-dimensional axis, one-dimensional grid, a position is just a number. It's a single number. If it's positive, we're right of the 0. If it's negative, we're left of 0. In a two-dimensional grid, a position is an ordered pair. But here, it's just going to be a single number. So find the position of a particle at t equals 3 if the particle at any time t is given by this equation. So we can go s of 3 equals, probably easiest not to use synthetic division here, although I still love it. You get negative 2 times 3 cubed plus 3 times 3 squared plus 2, which is negative 54 plus 27 plus 2, or negative 27 plus 2, or negative 25. Check me on that one. Okay, next, find the position of a particle at t equals 3 if the velocity of the particle is given by this and the position at t equals 0 is 2. I want you to read this question again for a second. I'm going to pause the video for a little bit while you just kind of read it to yourself because you have to absorb what it says. Resuming, how would you go about finding what the position at t equals 3 is? Simba? Okay, so integral of v of t. I'm going to stop you there for just a second when we do it. We're going to go, this is going to be negative 6t cubed over 3, so negative 2t cubed plus 3t squared plus a constant.
Then set the t's equal to 0 and make that all equal to.
Okay, so I'm going to stop. You're right. This is the position function.
Yeah.
So we're going to use the ordered pair 0, 2 to plug in 0 for t and 2 for s of t. And I get 2 is equal to c. So then I have s of t is equal to negative 2t cubed plus 3t squared plus 2. And now? Yeah, which happens to be the same equation as we did right up above. So S of 3 was negative 25. So we're seeing a lot of the same stuff happening, and I'm trying to point out to you that this is by design. You guys are looking at a litany of the similar type of operations because we're going to arrive at some easier ways to do things that we have to make sense on why this is happening. So what we're getting at is, I know, and I'm going to kind of write up here above this in general. I'm trying to see how much space you guys have on top of that. I see your paper. You got a little bit of space there. Right up here, we saw that with displacement, S of B minus S of A is equal to the integral from A to B of V of t dt. This right here is one reminder of the displacement. And we're going to use that because if I add S of A to the right side, I get this equation. The position is given by the position at t equals a, which could be any place, plus the integral from a to b. Do you see how this equation right here is just a variation of the one we did right here? I just added S of a to the other side. Now, it does not have to be position velocity. We can generalize with any function and talk about a function and its derivative. So the function at x equals b, given its value at x equals a, is given by this. The value at b is equal to the value of a plus the integral from a to b of the derivative, which then finally gives us to a better version of this. I can actually create a function, f of x, that's wholly based on having another value of that plus its derivative. And this, I want you guys not only to star, but there are a few times I give like a statement that I truly mean. This is the most important formula you will use on the AP exam. Most important. When I refer to that one formula from time to time for the next couple months, it will be this formula I'm talking about. It's used at least a dozen times on different AP exams I've seen. And its value is stupendous because it can avoid a lot of work if you know what you're doing. So when do we use this and when does this come up? Let's look at number 5. The velocity is given by this. Its position at t equals 2 is this. Now find the position at t equals 5. This is a dead ringer for when you use this, because I know position is the integral of velocity. But as a shortcut, rather than find an indefinite integral and then plug into to find out what that c value is, and then plug in 5, we're going to just kind of step back and say, I know that v of t is s prime of t, and I know that I have the ordered pair s of 2 is equal to 4. Again, a dead ringer for putting this whole thing together. So the way I start this is just by saying I want s of 5, and that's going to be equal to s of 2 plus the integral from 2 to 5 of s prime of t dt. Now we just substitute the values we know. S of 2 is 4. The integral from 2 to 5 of s of t dt is the integral from 2 to 5 of 3t squared minus 2t dt, which is 4 plus a t cubed minus a t squared, evaluated from 2 to 5, or 4 plus, do you guys really want to know the single best way to evaluate this without really worrying about the 125? In my head, I actually factor out the t squared, and I make it t squared times t minus 1, so then it's 25 times 4. Just saying. You don't have to, but that's what my brain does. So 25 minus 4 gives me the 100. Minus, then I'm going to do the same with the 2, because 2 squared is times 2 minus 1 is just 4. And that gives me 100. And congratulations, you guys have just applied the most important formula in all of calculus for the first time. Let's do another application of this, one that's a little bit more abstract. And it's abstract because it's not a velocity and it's not a particle. Not that a particle is not abstract. I mean, you can't really hold a particle. But it's literally asking to find f of 5. And it gives you f prime, and it gives you f of negative 2. Well, before we do that, I want to restate this most important formula in all of calculus relative to this. I know that f of x, any input, any x value, is going to be equal to the one it gives me. It gives me f of negative 2 plus the integral from negative 2 to x of f prime, which is 2x minus 3. Now, I'm not going to put x. I'm going to put 2t minus 3 dt, because I don't want to confuse what my x's are. I don't want to use x twice to mean different things. This x here matches my input, which is the upper limit. So given that, I'm going to show that f of 5 is equal to f of negative 2 plus the integral from negative 2 to 5 of 2t minus 3 dt. F of negative 2 is 3. Integral is t squared minus 3t, evaluated from negative 2 to 5, which is 3 plus 5 squared, it's 25, minus 15, minus 4, plus a 6. So 25 minus 15 minus 10 is actually 0. It's just equal to 3. Pause for a minute. Hello, Kendall. And let's talk about distance traveled. So I'm going to stick the word traveled here, which I apparently have written on my notes for a couple of years and still haven't gone back and just edited the file to say distance traveled. But distance traveled is what we're talking about. Now, distance traveled in a 5,000 meter race on the cross-country course is what? A little what? A little under 5,000 meters, except I think it actually evens out with the amount of like moving back and forth you do when you're passing. But no, our course is a little short. Spoiler alert, not all 5K races are 5K. The variance is allowed. A great deal of variance is allowed. They're about plus or minus 30 to 40 meters, depending. However, all 5,000 meter races on a track are 5,000 meters. That's why track is so much more precise and cross-country is not. Okay, particle moves along the x-axis. Its position is given by this. Find the total distance traveled in the first 3 seconds. So I am a particle. Here's my little particle here. And it's going to move. Watch, I'm going to animate this. It moves here, stops. Then it moves here, stops. Then it moves here, stops. Then it moves there, stops. And what do I really need to know if I want to know the total distance traveled? Let's say that this is negative 4, this is 3, and this is 1. And it goes like this. What would I want to know? Even better. What's the key things I need to know about when it turns? What happens when it turns? Yeah, velocity is 0. I need to know when velocity is equal to 0. So the whole idea of a total distance traveled is you need to know when it stopped. Because it stopped, when it stopped, it turned direction. Unless it just stuttered and tried to keep going, but nah. So that means I need to know when v of t is equal to 0. And v of t is the derivative of s of t, and s of t is given. So v of t would be 2t squared plus 2t, getting plus t, minus 3. And that is equal to 2t, 3t, I know, I factor strangely, minus 1 plus 3. So it is stopped at t equals negative 3 halves, which we're going to ax out because our times are considered positive, and t equals 1, which we're not. And it wants it to know in the first 3 seconds. So given that it wants it to know the first 3 seconds, and I know that it stopped at t equals 1, I now need to know the position at 3 places. What are they? S of 1 and S of 3. Well, S of 0 is easy. S of 1 is easier. I'd go right to left on that one. 1 plus a half is 3 halves, plus 2/3. 3 halves plus 2/3. Hell, let's write it down instead of trying to do this whole thing in our hat. 3 halves plus 2/3 is 9 plus 4 over 6, or 13/6. And S of 3 is 3 cubed divided by 3, but then times 2, 18, plus 3 squared times 1/2 is 9 halves, minus 9 plus 4, which is 13, or 26 halves plus 9 halves, or 35 halves. That's where it is at each of those different spots. So now what do I have to do? Yeah, I need to find differences between them. I kind of like doing this. I'll draw a connection between the 4 and the 3/6, and just do 4 minus 13/6, which is 24 minus that, or 11/6. So there's 11/6 of a difference between S of 0 and S of 1. And then I will draw it again between the 13/6 and the 35 halves. 35 times 3 is 105. So 105 minus 13 over 6, or 92/6, which for some odd reason, not odd, I'm not going to put into thirds just yet. You see why? This is the difference between the one, this is the difference between the other, and the sum of those is and it actually says S is measured in feet, so we'll put that feet unit on the final. Make it all good. Nitya. Sammy.
When we were doing this, last semester we did absolute value of those differences.
Same thing. Yep. This is just acting as a big review of all that too. Okay, moving on down. The graph of the velocity function is shown. When is the particle stopped on this graph? It stopped where? At t equals 1. This is when the value of velocity, again, you have to kind of cheat and see that this is the velocity function. When is it moving to the right? Yep. Moving to the right when velocity is greater than 0, which happens when t is greater than 1. And it's moving to the left whenever velocity is less than 0, which is when t is between 0 and 1. Actually, I can include 0. Can't include 1. And then let's say instead of t greater than 1, let's be more correct and say 1 is less than t is less than or equal to 3, since this graph is only between 0 and 3, according to the domain of the directions. It says that it's in between 0 and 3, so we have to kind of chop it off. Okay. It may be hard to see, but this graph is actually the graph of the same thing from up above. This is part of the same problem. So what is the particle's displacement between 0 and 1? What is it? Oh, so close. It's asking for displacement, so be careful about the sign here. I did absolute value when I was adding these, but this is going to be s of 1 minus s of 0, which is do I keep the sign? This would be negative 11.6 feet. It says indicate units and direction. So you can say negative 11.6 feet, or you can say 11.6 feet. Direction would be left. Okay, then we're going to do between t equals 1 and t equals 3. So s of 3 minus s of 1, which we've also already done. That is positive because 35 halves is more than 13 sixths. I'm going to highlight these so I can kind of keep those in my head. So that's 35 halves minus 13 sixths, and that is the 92 sixths. And 92 sixths is going to simplify to 46 thirds, which I can do here because I'm not using it for anything. That's 46 thirds feet. And if I were to indicate direction, I would say to the right. But the positive already indicates that. Whereas this negative 11.6 feet, or you can say 11.6 feet to the left. Please, do you guys understand how you can't say negative 11.6 feet to the left? You're double negating yourself. You got to pick one. Okay. Total distance traveled. What? You don't. You don't as long as you're consistent with your notation. If I put negative on one, then I'll just keep the other one positive. I'm fine with that. I just kind of, I'll put that in parentheses so you can say, like, see, optional. What is the total distance traveled? We did that. Yeah, 103.6 feet. Okay, next page. In general, the distance traveled by a particle between t equals a and t equals b is given by the absolute value of the integral. So just to review, what is the integral itself? The integral of v of t without the absolute value is not distance, it's what? Yeah, that's displacement. If I don't put the absolute value, it's displacement. If I do have an absolute value, that is distance traveled. Your calculator can calculate the absolute value of different operations. So at times you may have calculator problems that do that. Otherwise, manually, that's where you guys have to figure out where v of t is equal to 0, change the graph, and do separate breakups of it. So number 8, a particle moves along the x-axis. Its position is given by this. Find the total distance traveled in the first 3 seconds. So first step. V of t. We want to know what v of t is. V of t is 6t minus 7. Next step. We actually need to figure out what the integral of 6t minus 7 is from t equals 0 to t equals 3 of dt. But again, you have a different way to do that. You can do it by actually calculating the integral, which means we're going to break this integral up into 2 pieces. Or you can completely go back and do it the same way we did it on the previous page. That's okay. This is not that difficult a problem. I'm going to show this in a more calculus way because I want you to see the calculus breakup of this. So where is v of t positive and where is it negative? What's the critical value? What's the 0 here? 7/6. And will you agree with me that it's positive to the right of it and negative to the left of it? And instead of putting arrows on the right, let's just put chop-off bars because we're going from 0 to 3. Can you break up this integral now for me? if I want to find the absolute value, how do I split the integral up into two pieces? 0 to 7/6 of 6t minus 7. Now, the 6t minus 7 is a negative part, so I want it to not be negative. So you can do that, or I can just stick a negative in front. Plus the integral from 7/6 to 3 of 6t minus 7. I forgot my dt's. dt, dt. This is taking the sine graph we just did and using that to figure out two pieces for this. This piece right here corresponds to this piece where the graph was below the axis, but I want to force it to be positive. Do you guys remember vaguely from Algebra 2 when you would take an absolute value and split it into a piecewise? And I want to kind of focus on that for just a second, so let me move over into here and just talk about y equals the absolute value of 6t minus 7, just as a straight up function. You can't do anything with absolute value until you split it into piecewise. So what I tell my students is, first of all, decide when 6t minus 7 is actually equal to 0. When does that occur? That occurs at 7/6. So you're going to have different things happening when t is greater than or equal to 7/6 versus t is less than 7/6. When t is greater than 7/6, the function operates as if the absolute value wasn't even there. It's not even needed. That just becomes 6t minus 7. When t is less than 7/6, the function is negative and it becomes positive. So another operation that does that is to make the 6t minus 7 be negative. And that creates the split where you can do different integrals among the different parts. If you integrate an absolute value, you are truly splitting it into multiple pieces. If I do an integral of a curve like this, and I want to have the integral of the absolute value of the curve, which sections pop up and what changes? If I was doing the integral of the absolute value, don't all of these areas become positive? So the areas below the curve bounce up, and it's really fun to take a graph, for me, fun, different definition, and reflect it so that everything appears above the axis. So this is what happens if I were to draw that graph above the axis. I still have that piece. This one goes up, this one bounces up like that, this one's like this one changes, and that one goes up. So that my graph actually looks like this now, where every piece that was below the axis now appears above the axis. And if you're doing an integral, you have to split it up among all those different pieces so that the ones that dip below the axis, you change the sign. So back to this. This is the operation we're doing. This piece on the left appeared below the axis, so I had to flip it back up. Now, let's actually evaluate that integral with the limited space that I gave you and gave myself. And I'll try to shrink this and put this up just a little bit. Oh, got to grab the 3. There we go. You move up there. Okay, so 6t minus 7, the integral is t squared over 3t squared minus 7t evaluated from 0 to 7/6. And that is negative, or, and Sammy pointed this out before, you can flip your limits and do it the other way. You can go from 7/6 to 0, because that's a way to distribute the negative. Plus, still have the same 3t squared minus 7t evaluated from 7/6 to 3. Just for fun, let's try doing this without a calculator. Negative 3 7/6 squared is 49/36 minus 49/6 plus 3 plugged in gives me 27 minus 21. Then minus, that's the same 3 times 49/36 minus 49/6. So I get 21 minus 20, 27 minus 21, it's 6. Negative, I can do a 49/12. 49/6, if I want to change that over into twelfths, is 98 twelfths, which is the same as this minus right here, right? So can I stick a 2 in front of that? Because there are two of them. This and this are the same thing. And then I've got negative 2 times negative 49 twelfths plus 6, or 49/6 plus 36/6, or 85/6. Don't worry, your AP exam won't test your fraction adding capabilities. They know you have a calculator, at least for that part, those parts. Okay, a couple more. How are we doing on time? Number 9, a particle moves along the x-axis. Its velocity is given by the graph shown below, and its position at time t is equal to t equals 0 is 2. When is the particle moving to the right, to the left, and stopped? Easy enough, right? When's it moving to the right? Yeah, right is from 0 to 4. So I'm going to just kind of put 0 to 4. Let's include 0 because it's positive there. But let's not include 4 because it's negative there. Or it's at 0 there. I'm going to do this in interval notation just to kind of change it up, right? 0 to 4. When's to the left? 4 to 10. And when's it stopped? So just keeping that in mind, flip to the next page. I just copied the graph over because I had dead space, so I might as well just move the graph over there as well. What is the displacement of the particle between t equals 0 and t equals 4? So displacement is, remember we want to know s of 4 minus s of 0. Well, do I know s of 4? This is the graph of v of t. Gotcha. That's the first little gotcha thing we'll do. It is the integral. That's the integral from 0 to 4 of v of t dt. And the integral is area under the curve. So count boxes, everyone. 1, 2, 3. Ooh. Yeah. Let's do it like this. And then like this. And then like this. This is 2. This is 2. This is 3. And this is 3. I like that better. So 3 plus 3 plus 2. Oh, no, that's not 2. This whole thing is 4. 3 plus 4 plus 2 is 9. In between t equals 4 and t equals 10. So let's break this down too. That's 1. This whole thing is 1, 2, 3, 4. 8 and 2. So 8 plus 2 plus 4 plus 1. I'm going to write this down. S of 10 minus S of 4 is the integral from 4 to 10 of v of t dt, and that's negative 15. Okay, what's the position of the particle at t equals 2? I'm going to pause this for just a second. Okay, this is a trick question. It's in the directions. It's way, 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 way back. Flip page back. It's easy to miss, and this is why we did it. Way back on the front page, you have t equal, or not front page, at number 9, you have t equals 0 is 2. So that's your clue, and I want to write that back down here, that t equals 0, at t equals 0, position is 2. So we have to do the most important formula in calculus now. And if you don't see that, you're going to miss the whole thing, and you're going to look at the graph and be like, oh, okay. Or worst of all, you're going to see t equals 2 and try to do the area under the curve between 0 and 2 and miss the whole idea that you actually have to add the initial position. So this is critical. So if at t equals 0, s equals 2, we're going to do s of 2 is equal to s of 0 plus the integral from 0 to 2 of v of t dt. And that is equal to s of 0 is 2 plus the integral from 0 to 2, which I can look at the graph and add up those things. That is 1 plus 1 plus 3, and that is 7. Okay. Now let's do that for s of 4, s of 7, and s of 10. They're all going to be equal to 2 plus the integral from 0 to 4, the integral from 0 to 7, and the integral from 0 to 10. So the integral from 0 to 4 of v of t dt is equal to 2 plus, what's 0 to 4 again? We did that up above. That's 9. 2 plus 9 is 11. Then we do 2 plus the integral from 0 to 7. I'm going to swing back up here and try to count these up. Let's split this up into 4, 4, 2, and 2. So this is 9, and then everything here is negative. So 9 minus 7, is that 2? And you get 4. And then the integral from 0 to 10 of v of t dt is 2 plus 9 minus 15, because we did the two pieces already, and that's negative 4. Okay, finally, what is the total distance traveled by the particle at t equals 2? How far did it go at t equals 2? What is it? It is, but we can also just do, because I know that it's not stopped anywhere in between that. We know the places where velocity is 0. So since it traveled from 2 to 7, I kind of think about, I know that at s of 0, it's equal to 2. So since I know all this, and I know that s of 0 is 2, s of 2 is 7, s of 4 is 11, s of 7 is 4, and s of 10 is negative 4, I really just need to know what the difference is between some of these. So at t equals 2, distance traveled is what? 5. It's equal to 7 minus 2. At t equals 4, distance traveled is, remember, it hasn't stopped yet. Or it's actually stopped at 4, but it's what? It's not 4. That's how far it got from t equals 2 to 4. What about from t equals 0 to t equals 4? Is it what? It is 9. 11 minus 2. It started at 2, and it moved to 11. 11 minus 2, give me 9. 7 minus 2 is 5. Sorry, I should write the 5 down. Okay, now let's go t equals 7. At t equals 7, we have to worry about the change in direction, right? It moved 9 units from, and I'm going to cross this one out because that one doesn't matter. It didn't really stop anywhere at t equals 2. But it moved 9 units from s of 0 to s of 4. So it's going to be equal to the 9 units it's already moved, plus how many units did it move between s of 4 and s of 7? Yeah, plus the 7 units it moved, which means my position is 16. And then finally, s of 10. So at t equals 10, it is 24. It'd be the 9 units it moved to get to position 4, plus the 15 units it moved after that. Even though it was negative, it still moved 15 units, and that's 24.